Hi, my name is Sai Devilapalli. I am a B2B marketing strategist and technologist. Today I'm going to talk about use cases for predictive analytics applicable to B2C enterprises. So we are talking about companies that have a large consumer base as their customers. For example, consumer electronics, retail, telecom, and so on. Predictive analytics is applicable to any business problem that can be modeled as a balance among three things: demand, supply, and price. Fundamentally, there are only two kinds of business problems: ones that try to reduce cost and ones that try to increase revenue. So if a company wants to increase market share, it has to predict the demand and then fine-tune the supply to match what it has predicted as a demand. And if it wants to increase its margins, then it would have to predict the demand and then fine-tune the price. So use cases that try to reduce cost are usually under the purview of the CIO of the enterprise, and use cases that try to grow revenue are usually under the purview of the CMO of the enterprise. And then you can think of enterprise analytics use case domains. There are essentially three domains. The first two are easy to guess. Enterprise resource management and customer relationship management. The third one is not so obvious unless you are a Google or a Facebook, and that is data monetization. Data monetization is about how you generate new revenue streams for the enterprise from the data generated by the enterprise. Regardless of the use case domain area, one important thing to note is that analytics use cases are never 100% complete or a one-shot deal. It's kind of like business transformation or business process improvement initiatives. It has to be done in phases, and there is always room for improvement. Also, the effectiveness of the implementation has to be monitored and fine-tuned across business cycles. So the key thing to remember is that if you have to prioritize new predictive analytics use cases along with upkeep and lifecycle management of existing predictive models, that's always going to be the case. Before we talk about analytics around enterprise resources or assets, let's talk about what assets are we referring to here. So we are talking about things like inventory, IT and business processing systems, financial assets, and so on. In certain industry verticals, such as utilities, energy, and telecom, enterprise assets also include things like infrastructure and networks that are owned and managed by the enterprises. Let's talk about inventory. Predictive analytics use cases can be built for things like inventory management, demand forecast, as well as supply chain forecast. A lot of companies that sell physical goods such as retail, consumer goods, network equipment, and even power companies are implementing predictive inventory, supply chain, and demand management. If we talk about financial assets, predictive analytics can be used for things like forecasting financials, such as cash flow, revenue for specific products or services or segments, markets, or for the whole enterprise. Detecting and correcting revenue leaks all involves learning to recognize what are called signatures for revenue leaks, and then automating the business processes that take corrective action to plug those revenue leaks. Financial fraud is also a huge area for predictive analytics, and especially real-time predictive analytics. Why is real-time important? Because immediate action may need to be taken to stop fraud before it happens or to limit the financial damage after it has happened. Fraud is often preceded or followed by certain behavioral signatures which can be learned. And that said, fraud signatures constantly keep changing, so the machine learning needs to quickly adapt to these changes to limit the financial loss due to fraud. Finally, under enterprise resource-related data analytics, let's talk about predictive analytics around IT and network infrastructure assets. Here we are talking about predictive failures of network and IT infrastructure elements, predicting capacity needs and proactively scaling the network and infrastructure up or down to match these needs. Network and IT infrastructure may also need fine-tuning and optimization for maximum performance. Now there's a concept called self-optimizing networks. These are networks that use performance metrics to go back and automatically tune themselves for optimal performance. Self-optimizing networks that are tuned using well-defined predictive models can actually represent significant operational savings for enterprises and that have to manage these network infrastructure on a day-to-day basis. So here we're talking about industry segments such as manufacturing, energy, telecom, and so on. On the IT infrastructure side, predictive analytics can be used to trigger IT and business processes proactively by learning how past events and conditions have led to past IT and business outcomes. Use cases here are primarily in three categories. One, how do you retain existing customers? Second, how do you upsell to existing customers? And third, how do you add new customers? Data analytics on existing customers is usually easier to implement than data analytics on new customers. Why? Because existing customers interact with the enterprise, and that generates a lot of data that can then be used to figure out the next best action for that customer. Imagine the task of improving conversion rates on anonymous site visits. This is a difficult task because the enterprise needs to rely on third-party data about the potential customer, and the enterprise may only get a limited number of chances to onboard this customer. So from a data analytics viewpoint, focusing on existing customers is definitely the low-hanging fruit compared to looking at new customers. So that's what we will focus on in this talk. The holy grail of predictive analytics on existing customers is to make each customer feel that they're the only customer. This is important to retain the customer, improve loyalty, and then make them buy more from the business. To achieve this, first you need to understand the customer. This means understanding who the customer is. That is, what is their demographics? What is their psychographics? Then you need to understand the customer sentiment, or what the customer is experiencing along different dimensions of your product offering or your services offering. And then you need to understand, what is the customer planning to do next based on their touch points with the business. And then finally, you need to understand how important is this customer to the business, either from a customer lifetime value point of view or from a social influencer point of view. So you need to have a multidimensional vector on each customer with these attributes. Now, once you have understood everything you can about your customer, then you need to figure out what is the next best action. Is it an upsell or a cross-sell opportunity? Do you have to offer a promotion to the customer? Do you have to make an attempt to retain this customer because they have a potential to leave? Do you have to proactively reach out to the customer about an issue they're having? Do you have to provide informational guidance to the customer? And finally, the most important action, do nothing. There are primarily three mediums to engage with a customer on one-on-one basis. Digital medium, phone calls, or retail locations. Of all these mediums, digital medium is obviously the most cost-effective option, especially if it's self-care and self-service oriented. So far, we talked about two predictive analytics use case domains: enterprise resource management and customer management. Let's wrap up this session by talking about the third one, enterprise data monetization. The concept here is enterprises generate a lot of data, and predictive insights from this data can be sold to third parties. Data monetization is the main source of revenue for companies like Google and Facebook. But most other enterprises generate revenue from selling other products and services. So data monetization becomes an alternative source of revenue in what is called as a two-sided business model. There are several challenges in data monetization for enterprises that don't have advertisements as their primary source of revenue. There are often regulatory requirements, for example, in healthcare, insurance, and the telecom sector. There are cultural barriers as well. Paying customers may not be open to businesses selling their data in addition to charging them for the product or service. On the other hand, users who are getting free service may be open to trading off some of the privacy for the free service. So for this reason, most of the data monetization use cases so far have been around monetization of aggregate data for generating statistical insights. For example, in retail store planning, city planning, government services, etc. Therefore, data monetization, I think, is still a nascent use case domain in predictive analytics for B2C enterprises. To summarize this section, we have talked about three predictive analytics use case domains: enterprise resource management, customer management, and enterprise data monetization. The first two use case domains are likely to mature in predictive analytics in the near future, whereas data monetization is still in a nascent state as a use case domain. Thanks for watching.